Thank you all again for coming to this meetup and showing us your support despite this beautiful weather. Really appreciate it, and you survived. Awesome. And also I would like to use this opportunity to thank our awesome sponsors, A2C, for sponsoring pizzas and drinks. Cognizant, so there will be a book raffle. Today's raffle will be The Power of Process by Kiran himself. So it's a beautiful book. And then Reduce, as always, for being an awesome host to these amazing venues. Really appreciate that. So before we get to the talk, a quick shout out for Analytics Week. So we are conducting an Analytics Week from March 24 to March 29. And we are seeking organizers, sponsors, speakers for the session. And if you are interested, send an email to sachin@analyticsweek.com. I will also post it on Meetup page. So looking forward to your effort and sort of on showing up there as well. Thank you. And without wasting further time, let me call on Kiran. So Kiran has been, so I just recently got to know Kiran from a common friend of ours, and the moment he introduced me to Kiran, so he is an awesome guy and doing some interesting stuff in process space. So without further wasting time, I should, Kiran, thank you. Yes, please.
Why don't you guys just move closer so I don't have to shout as much?
There's a mic also if you want that.
Nah, that's okay. Hey, thanks, Vishal. Hey, so first of all, I really appreciate you guys showing up. I had to be here anyway for a different event. So braving all this wonderful weather. So when I got the shuttle from my hotel for my destination, you know, everyone was asking me, "Is this all that you're going to wear? That's it? Aren't you feeling cold?" And I said, "You don't understand. I am from Milwaukee. And this is like nothing. We bring out the t-shirts when it's this weather. So right now it's like 12 degrees out in Milwaukee, okay? So it's a big change for me. It's beautiful. But I know for you guys it might be a challenge, so I really appreciate you showing up. Now, I want to speak on a very interesting topic that it's been sort of dear to my heart for several years, decades actually. Professor Zhihong Tang here, who just spoke, he and I have been to the same program at University of Florida in the Decision and Information Sciences Department, College of Business Administration. And we both got our PhDs from there with the same batch, and we know each other for many years. We're close friends. And so he understands some of the issues that I'm talking about. We have seen a lot of these revolutions come and go. Right. So today you guys are all about big data, visualization, social, mobile. In the past it was ERPs and Corba and Complex and object technologies, etc., etc. We have seen a lot of these things happen. And coming from a quant school like University of Florida, which is, you know, multi-criteria decision-making bent to that, you know, there are some really interesting things that are, you know, it's an established field, but we haven't seen this applicability of that in corporate America. That's the gist of what I'm going to talk about in the context of analytics, right? And I'm not an expert in analytics by any stretch of imagination, but this is something that I really want to talk about. For several years, my real expertise and field has been in business process management. So, you know, until recently, I was with Software AG as an evangelist for their BPM practice and also a consultant. And prior to that, I was a global CIO for General Electric, one of their small $8 billion companies. And it's been terrific, right? So I've done BPM all over the place, and I've written a book about it, which you'll see on Amazon. and it's also adopted as a supplemental textbook at various universities for their MBA and executive MBA programs. So I've been very fortunate to have this kind of experience, and it's been a great ride. I just love it, okay? But today, I'm not so much talking about process management. I'm talking about this other aspect of corporate America that very few people are exposed to, okay? So when I was the CIO, and I've consulted at 20 different countries. I've gone to so many different countries. I've spoken at events all over the place. I've written a number of blogs and so on. And most of my conversation, I'm not a techie, okay? I don't code today unless, I can actually be, as I was mentioning, fairly dangerous in PHP and MySQL, okay? And some JavaScript and jQuery, that's about it, okay? But I'm not like, some of you guys you'll run rings around me, I know that. But my interaction has been very much at the senior manager executive level, okay? When I have these conversations with these people, okay, technology is not their stumbling block. It is not their stumbling block. The stumbling block for them is, what the heck do I do with this technology? That's their stumbling block, okay? So I'm going to dive in, and by the way, it's a nice, small, cozy group, so please stop me, we can have a conversation about this, okay? So let me jump into this one. So, in my early days at GE, when we were doing a bunch of different projects, one of my stakeholders was the vice chairman of the big GE. So really a big guy up there in the board level, right? And he and I were having a conversation in the corridor. And he said, Kiran, this is, so we were trying to do BI, and, we had a lot of data issues. We were implementing business intelligence with business objects and so on and so on. And the company was facing a lot of issues getting reports and data so that they can run their business, right? And so, we just ran into each other in the corridor, and he said, Kiran, this is so funny because 20 years ago, right, there's something called the MIS department, right? You submitted a request, and some of you guys may remember this, right? You submitted a request, and 2 hours later, they gave you a report, right? That's what they did. And, when I started my career, right, we had punched cards. So you had your deck of punched cards, you wrote your COBOL program or a BASIC program or Fortran, and you handed it in through a closed window, and like you go like a bank teller, right? And 2 hours later, you get a ream of output. And guess what? It won't run because you misplaced one comma somewhere. Bummer. So you go back and you look at your cards, you kind of read your ASCII code on the cards, and you substitute that with the right one, and then you submit it back, wait for another 2 hours, right? This is a cycle that you went through. But guess what? Every morning, he got a report of how revenues and sales and other metrics, KPIs that he was interested in, on his desk. How accurate and true they were, we don't know. But the fact is he got them, okay? And he was telling us that, how come you guys can't produce all this stuff? Okay, boss, it's a different world. It's a lot more complicated now. We know that, but there's no excuse, right? We got to be able to do that. So, at the end of the day, I know we talk about really cool stuff like, big data, social, mobile, all sorts of visualization, all really, really, really fantastically cool stuff. But if you can't help your decision makers make better decisions faster while at the same time minimizing risk, you haven't moved the needle at all. It makes no sense at all, okay? And I have seen all kinds of really cool data visualizations running around. And the techie in me says, oh, this is absolutely fantastic. D3JS, beautiful. Man, those guys are awesome. Data-driven documents. It's fantastic, right? I love that stuff. But the other side, as a business guy, I look at that and say, okay, cool. So what? There's a Voronoi map. Okay, beautiful. So what do I do with this stuff? Help me there, okay? That's the missing mile that I want to talk about, okay? Does that make sense? Okay. How many guys in the audience, by the way, are hardcore statisticians? Statistics? Some of you are saying, what's that? Okay, that's fine. I'm just kind of curious. So this is the question. So to some of the guys who responded, do you know what classical statistics is versus Bayesian statistics? Yeah. Okay, so you kind of know some of these things, right? So you'll see some of those things. I'm going to play them out a little bit. Okay, but to come back to the point, right? What do we give our stakeholders? All these acronyms. right? That's what we inundate them with. You guys know what TLAs are? TLA? 3-letter acronym. Okay. You know what a 4-letter acronym is called? Anybody guess?
FLA?
4-letter acronym, huh?
FLA?
FLA? No. In the best traditions of the IT guys, it's called ETLA, extended TLA. Okay. But this is what they want. This is what they care about, right? All of your business users care about this. Okay. So how do you translate from one to the other? That's your big problem, isn't it? So I want to walk through, I don't know how well you guys can read all this stuff, but I'm going to walk you through the life cycle of data, right? You guys know this stuff, so I'm going to breeze through this, right? You got your acquisition part, you got your collection, you got your cleansing of the data, analysis, packaging it up, consuming it, making some decisions based on the data, right? That's your life cycle of how it goes. And what is the predominant, most widely used data analytical tool out there?
So.
Thank you. It's Excel. I've asked this question in 20 different countries, and that's a consistent answer that I get. I spent $3.5 million of my budget implementing a BI solution for my company, business intelligence solution for my company. Okay? Guess what happened? They would get those reports, dump them into Excel, and do further analysis based on that. Okay? So what's missing from all this, right? It's that last mile. How do you look at this stuff and actually make a decision? I have been in so many management meetings with my CEO, my boss, and my functional peers. Okay? And we look at these dashboards like you wouldn't believe them, right? We look at Excel, we look at BI, we look at Cognos, you look at, with other, reporting mechanisms out there. We look at those dashboards and we debate until the cows come home and have given milk and gone to bed, but we can't understand what are the root causes of why certain indicators and KPIs are red or green or yellow. We just can't. And invariably, they all turn to me because I'm supposed to know about information. I'm the CIO, for crying out loud, okay? And they'll say, can you, Kiran, go and find out more information about this? And I say, sure, give me 2 weeks, I'll get something done.
What's KPI? And also, when you bring up these new acronyms, can you tell us
Oh, I'm sorry. Key performance indicators. Key performance indicators. Okay? That's what it means. And you'll see some of these. I think I have some examples going on. Okay. So what we have not done is we have inundated our users or business audience with a bunch of nice, beautiful reports and dashboards and whatnot, but we haven't given them a consistent and systematic framework for working with that information. That's the problem. What do you do with that information, right? It is almost like taking a bunch of letters and making books out of these things and putting them in a huge library, right? You wander in, there's no catalog, there's no index, there's no subject, so you don't know how to go about searching for stuff. It's that equivalent that we have created for, many of our users, right? At least that's what I see from the other side of the table, okay? Not as an IT guy, okay? I want to talk to you about the case of the missing 300 million. One of the challenges that, my boss gave me when I, joined GE, he said, and I was the first CIO for this company, and it was a small $2.2 billion company then, and in 4.5 years it went to like $8 billion. So it's pretty nice growth rate, okay? So the very first thing he said is, Kiran, I think, the $2.2 billion in sales volume, I think we're sort of off somewhere. We are probably missing a couple of $100 million somewhere. I said, how can you run a $2.2 billion, such a big company and miss $120 million? You're so casual about it. I'll be tearing my hair out. He said, yeah, I know, it's about 100 million, but that's why we want you to find it. Okay? I said, sure. So I got the marketing managers, the sales managers, the VP of sales, VP of marketing, the CFO, and collections expert, risk manager, and so on, and I put them they're all my functional peers, right? And I said, look, guys, help me out. So define what sales volume for me is, then I'll have my team run around and get all the data and we'll do it. And so, tell me a formula that sales volume equals A plus B minus C times D or something like that, right? So what is it, A, B, and C's? Would you believe it? There were 2 hours worth of bitter discussion about it. And there was no consensus. There was no consensus about sales volume. Okay? The sales manager said, it's what we sell. And the risk manager said, oh no. You've got to discount it for risk. You can't take that. That's no good. And the marketing manager said, aha, but you have to apply all these discounts and marketing programs, plans that we give you guys, right? You got to do that. And then the collections guy said, well, all the mistakes you risk guys make, we collect in the back end. So underwriting, you got to underwrite and you take that stuff out. Okay? You got to take out all those write-offs. Okay? So there's a bitter fight about this whole thing. And I had to engage one intern to come in and do a 2.5-month project. And then he came out and said, I'm done. It's a huge formula. That's what it is. And guess what? We found not 100 million, not 200 million, we found $300 million worth of missing sales volume. What does that translate to net income for this company? $6 million in net income. Okay. Have I earned my pay? Oh, you bet. Okay. Those are the so you tell me, what kind of challenge is that data-wise, right? You got reams of data. You got all kinds of sales data jumping out at you. You have your beautiful Hadoops and clusters and visualization tools and everything else. How will you detect that particular problem? How will you solve that? Think about it for a minute, right? If your tools and technologies could not solve that problem, you have just lost the company $6 million. Okay, in opportunity costs, so to speak. So the main thing, right? So what is the real main thing? I'll read this out for you guys in the back. After decades of decline, this is an example. The commercial jet accident rate flattened out during the past 5 years, leading many aviation experts to believe that the biggest future safety advancements will come from reductions in human error. Okay, so if you look at the flight data, the errors and fatalities have been coming down. We know that. Flights getting, how many guys know what Six Sigma is? Do you guys know Six Sigma? The continuous improvement. Do you know what is the Sigma capability of flight safety? Anybody?
The Sigma value for flight safety?
Yeah, what is the Sigma of flight safety?
Oh, I don't know.
It's not 6, it's 6.5 Sigma. Six Sigma is 3.4 million fatalities in, 3.4 fatalities in a million opportunities. And it's an exponential scale. So 6.5 it's like minuscule, nothing. Okay. Baggage handling on the way, just to give you a comparison, is about 4 Sigma. About 10,000, something like that. 10,000 bags lost per every million opportunities. So it's about 4 Sigma. But flight safety it's been increasing, right? We know that the crashes are going down. It's very, very good, right? Of that, if you look at the contribution to fatalities due to errors in the mechanics of the plane itself versus pilot error, the contribution from the mechanics has been decreasing. Okay, you understand? The engineering is getting better. That's what I'm saying. However, the rate of errors from human factors is flat. It's been pretty constant. So, guess what happens? When there are more and more flights, 2 phenomena happen. Number one, the proportion of errors due to human factors increases because the other side is decreasing, right? Plus, the number of crashes and other incidents will increase because we are doing more flying nowadays. You see that? Right? So that's the problem, right? So they say in all safety incidents reported, 45% had pilots caught by surprise, 60% had an error in using a flight management computer. Okay? And it doesn't add up to 100%. So presumably the 5 people, 5% had a problem using the computer and they were still caught by surprise, maybe. Here's the other part. This is a very recent phenomenon, by the way. Pilots are becoming addicted and over-dependent on their automation. Do you guys know, technically speaking, unless it's for landing and takeoff and a few minor emergencies, you actually don't need a pilot. The the instrumentation and the computers on your modern jets is unbelievable. Okay. Now, I've been a consultant for many years, right? I used to travel all over the place, and I had an inordinate fear of flying. So before every Monday, you leave off for this, jaunt. I'll get my wife and say, honey, in case anything happens, here are the papers, all this stuff. I used to be very scared of flying. And several years ago, I said to myself, this is ridiculous, because intellectually I know this is the safest form of transportation. It's an emotional thing, right? I've got to conquer that. So I actually went and took flying lessons. Okay, I started taking flying lessons, and I didn't complete it, but in 8 hours of flying lessons, I could actually take off and land, and once you're in the air, you can do hands off. It's no big deal. I mean, this is an old Cessna plane I'm talking about, okay? That's what I'm talking about. Modern jets, they've got the runways programmed of all the major airports programmed into their computers, right? So, you really don't need the pilots. They're just there for reassurance for the passengers. Looks like it, right? Well, they're there for, emergencies. We know that. So they're not completely indispensable. We know that. So the point I'm trying to make is that these people have gotten relying so much on the automation that now they don't know how to fly manually anymore. That's been a huge outcry. And this one is, by the way, Wall Street Journal, November 17, 2013. Pretty recent, okay? And there's actually a program on TV on one of the news channels, I forget which one, we were seeing, and they interviewed pilots, and they all said, yeah, you were kind of losing our skills. We just can't, pilot the plane manually. If everything fails, we just can't do that anymore. So they've lost that ability now, okay? This over-dependence on technology, it can be in our space, computer technology. You will look at all this cool analytical output that comes from some of the technologies that you guys are dealing with, and you're led into a false sense of security of how good those things are. There are pitfalls behind those analytical methods that you need to understand, okay? And that's what I'm trying to get into. Okay, can it make sense? This is what they concluded, okay? The National Safety Transportation, NTSB, concluded this. They said, but it's a complex area of research involving the study of psychology, decision making. I didn't write this, they did. I underlined it, of course. Training, relationship between humans and sophisticated automated systems. These are very important, right? You guys are, this whole field is in such a fantastic spot right now. You have the power to make a huge difference, not only technically in what you do, but also in how your users consume this. You want to make them better educated, more sophisticated in consuming this, right? It's a great golden opportunity for you guys, right? So we know that the technology in data gathering, storing, analysis, visualization, it's making tremendous progress. We know that, okay? But what about our ability to think? Yeah? What about that? Have we become personally better thinkers? Do we save our money, invest better? Do we pick the right alternative between choices? Do we do that? Okay? Would you put a kid in a Ferrari? So what you guys are doing, I don't mean to belabor this point to you guys specifically, but us in IT generally speaking, right? We are building a Ferrari, right? And we're giving the keys to a kid. We gotta put these people through driver's ed. We gotta do that. We just can't give the kids and say, go drive. They can be damages, right? We got to empower them and enable them the right way. Okay? So the analytical landscape, right? And this is what H.G. Wells said, great guy. Statistical thinking will one day be as necessary for efficient citizenship as the ability to read and write. And he didn't say necessary for scientists or intellectual workers or knowledge workers. For citizens, he said. I think that was a little too much. I think that's a little overstated. But you probably can read the black background on this one. This is classical statistics, Bayesian statistics, categorical analysis, logical thinking, and heuristics. Okay? So it's approximately, this is the most rigorous mathematically speaking, right? It has got a huge rigorous background, classical statistics. Bayesian is a bit of a revolutionary way of thinking. Now, I personally happen to be a Bayesian. I love Bayes. That's how I like to think. And I'll bet that most of you, whether you know it or not, are Bayesians. Whether you know it or not, you are all Bayesians. Okay, take it from me. Granted, I can prove it. Okay, so most people, classical statistics is very non-intuitive. Very non-intuitive. Some of you guys are statisticians? I'll ask you a question. You know the confidence intervals, right? Heard of confidence intervals, right? What does a confidence interval really mean? I'll give you an answer. People think it is the probability. If they say the confidence, it's a 95% confidence interval. It means that the probability of finding the mean in that or whatever statistic you're looking at, there's a 0.95 probability of finding it within that. Is that what you think? That's what people think, right? That's not what it means, by the way. It doesn't mean that at all. It simply means that if you run that same sampling experiment thousands and thousands of times, 95% of the time, your mean is going to be in that confidence interval, whatever interval happened at that particular point in time, right? That's all it's saying. It is not talking about the probability of finding the mean in that confidence interval at all. It is a confidence not in the estimation of the mean, it's a confidence in your procedure for calculating confidence intervals. You get that? I know it's very subtle, but these are things that will trip not just lay people, but even classical statisticians, right? Bayes is entirely different. It's natural. It's exactly the way we think it is. Okay? So enough of that. So I don't want to give it a dissertation on Bayes thing here, right? But we also have things like categorical analysis, which is data that's not numeric. Okay? Like the Likert scale, preferences, colors. What colors do you like? Okay? What are your preferences for me? So those are categorical nominal data. Okay? Ordinal nominal data. How do you analyze the data? There's a whole host of techniques for doing that, and one of the foremost experts in that is a gentleman, a professor called Alan Agresti, who recently retired. He's from University of Florida, and I don't know if you took a course, but I did. I took a course from him. He's written several books on categorical analysis, right? That's where you come to appreciate the nuances of what it means to, think and analyze stuff like that. Okay. Then, of course, you've got logical thinking, and we all like to think that we are logical thinkers, but that's a very illogical thought, by the way, which I hope to prove in a few minutes. Then we also have things like heuristics. Heuristics is also about, you ever heard the phrase called bounded rationality? Bounded rationality. Bounded rationality basically means that human beings are rational beings. We know that. That's true, of course. But we are bounded by some prejudices, biases, and misconceptions, and the available knowledge to us. We are bounded by that. That's basically what it means. And it's a concept that was pioneered by Herbert Simon, who is a Nobel Prize winner in economics, and also the Alan M. Turing Award winner for computer science, right? And if we ever get together and have beer, you can ask me about my meeting with Herbert Simon and my discussion with him for 45 minutes. It's a fascinating topic. But he's the one who, he and many others from, of all the places, psychology, the subject of psychology, right? They came up with these ideas about heuristics. And just so you know, Herbert Simon was also the founder of cognitive science. There are several journals on the cognitive science, and he was in the Department of Computer Science and also the Department of Psychology at Carnegie Mellon. Okay, and I met him right the day after the IBM's Big Blue beat Kasparov in chess for the first time, beat a grandmaster. Just the day after that I met him, and we had a fascinating conversation. So what I would say is it's not so much statistical, it's analytical thinking that should be, sort of part and parcel of our DNA going forward. Okay? Here are some examples. I won't read through all this stuff. It won't mean anything to you. It doesn't mean anything to me, by the way. I have no clue what this is all about, and I won't harp on this one. I'm not a statistician. Okay? But as you can see, in some of our packaged models, right, SAS is a good example, right? SAS is a good example. MATLAB is a good example. There are all these packages that you can plug in the data and click a button, and they'll give you some stuff. They'll say, here's your regression equation. Here's your p-value of your hypothesis. They'll give you this stuff, and you go say, oh, well, that's pretty good. Very nice. Not. So you have to be very careful on how you interpret some of these things. Okay? That's the point I'm trying to make, because there's a lot of nuance behind it. Let me give you one example. You all know this bell curve, right? The normal curve, the bell curve. Okay? How many of you have actually done or plotted the bell curve using data? You all done this stuff, right? So here's my question for you. How many of you have run the Anderson's test for normality before you actually did that? Do you know what it is? The Anderson's test for normality. The normal distribution makes absolutely no sense if your data is not normally distributed. So there's a test you have to run before that to say, yes, I think the normal distribution is plausible for my data, and therefore I will use the normal distribution and plot it. Okay? Most people don't know that. They'll just plot something. And they'll say, it's normal. Oh, here it is. Not. Okay? So there are, believe me, thousands of such nuances in classical statistics, and in Bayesian statistics, and in categorical analysis, and so on.
I was just wondering, since you're talking about statistics, and statistics on large part based on calculus, would you say it's a mathematical issue that most people just don't know?
It's actually not based on calculus.
I mean, the integration of the
yeah. To that extent, it's an integral, right? Yeah, that's an integral. I agree with that. And for a standardized normal curve, the integral is 1. Okay, yeah, we know that. It is not a mathematical misconception. It is a statistical misconception. So let me step back for a second. You may wonder why all this is happening, right? Human beings, right? We are fantastic cognitive machines. We can take 2 or 3 instances of something and generalize that. Okay, we can generalize that. When we use the word chair, right, we mean chairs of all kinds and colors and shapes. Chairs with 4 legs, with 3 legs, with roller wheels on them, with armrest, without armrest. Chairs that have existed in the past, that are existing today, that have not yet come into being and will do in the future, etc., etc. Okay, so this is the twist on the familiar saying, a picture is worth 1,000 words. Actually, a word is worth 1,000 pictures. Actually, if you think about it. Okay, so we use words conceptually. We are not like animals. Animals don't view the world like we do. Okay, we are excellent cognitive machines, but evolutionary wise, right, we have only dealt with very limited small samples of data, and we generalize using very small samples. Okay? The modern world is very different. It generates data in unbelievable quantities. And the techniques that you use to infer for inductive generalization on this are very different, and they are fraught with all kinds of pitfalls. All kinds of pitfalls. Okay? And there's a lot of really interesting examples, how that happens. And, I can suggest some really interesting books. Very simple examples. And you'll say, whoa, I never thought of that one. Okay? That's because we are not trained to think like that. We make mistakes all the time in probability theory. We do that, okay? And I'll show you some examples, but so hang on for a second. Here are examples, speaking of which, okay? Logical fallacies. So here are some examples. Affirming the consequent, if A then B. B happened, and then you conclude therefore A. That's a logical fallacy, right? It doesn't happen like that, okay? There are lots of these argumentums. These are all Latin terms, right? Argumentum ad baculinum, argumentum ad crumenum, argumentum ad hominem. You know ad hominem? You guys know what an ad hominem attack is, right? It's attacking the person, right, and not the argument, okay? Oh, you're short, you're fat, you're tall, you don't, etc. That has nothing to do with the argument about, right? So those are some examples. Populum, playing to the crowd, pleasing Wall Street in a modern context. Okay. Argumentum ad verecundiam. This is important. Appeal to authority. I'll tell you, I have a PhD, I'm a CIO, what I say is right. And you say, oh, yeah, this one. That's bullshit. That's argumentum with authority, right? The fact that who I am has nothing to do with the argument. I can claim some really ridiculous stuff, but my credentials have nothing to do with that, okay? But people fall for this all the time, okay? And so we got to watch out for that. And why this is important is the conclusions that people come to by looking at your data can be subject to some of these fallacies.
Isn't that Bayesian though?
Which one?
The last one.
This one?
Or ad hominem.
Yeah. There is a play, the Varacundium.
I mean, if you're a Bayesian, wouldn't that make sense?
Only in the following circumstances. If I speak with authority about my particular field, then it is plausible that I'm right. Not certain. It's plausible that I'm right. But what happens today is that you've got a politician who has absolutely no training in economics who will make all kinds of statements about economy. Okay? And it's not maybe not us, but the lay people believe that. Why? He's the president. Okay? Or an economist will speak about psychology, but they have no training in psychology. An economist will try to do stock market investing and trading and run a hedge fund. Okay? And there are 2 Nobel Prize economists who did that and ran this fund into $2 billion worth of losses. You know who I'm talking about?
Long-term capital. Long-term capital.
LTCM, thank you. Black-Scholes.
I think it's like 10 billion losses.
You said, is it that much? I'm off by 2 billion, 10 billion, it's all the same. You know. And to make matters worse, Scholes went on to found another company after that, and he lost another 600 million. So how much money do these people have to lose before you take away the Nobel Prize? I don't know. Okay. Again, begging the question. You kind of know this stuff, right? Begging the question is an example of that. Why is a restaurant crowded? Well, because everyone goes there. Okay, well, hello. Yogi Berra had a classical twist on this one. Somebody said, why don't we meet after the game? Why don't we meet at that restaurant? He said, it's a popular restaurant. He said, no one goes there anymore. It's too crowded. So, false alternatives. You see this all the time. Sell more to your customers or become unprofitable. Oh, you can keep selling more to your customers and still be unprofitable. Or you can be profitable without selling anything more to your customers by cutting down your costs. So there are other alternatives to this, right? So that is called the argument of the false alternative, right? And I won't read through all this, but just to give you an idea. Hey, this is an interesting one. Dad says, smoking is bad for you. The kid says, well, you smoke. Which means I'm not going to take your advice. What has that got to do with advice? Advice is still sound, right? The fact the guy smokes and he says don't smoke, that shouldn't contradict each other. The advice by itself is still good, right? So people get into this, by the way, that's not me. So my kids don't smoke. That's not. Oh, so just for fun, right? We'll just go through a few riddles. Is that okay? Just go through a few riddles. And let's see how we do. So here are 2 examples. Town A. This year, crime has increased 80% compared to last year. Oh my God. Okay. On Town B, crime has increased only 10% compared to last year. You see this stuff like this in journals all the time, right? Media reporting this stuff. Which town would you pick to move to? How many would pick Town B?
We have to talk about what's baseline.
From now on, you're not saying anything. But you see the point? You guys get this, right? But lay people will make this mistake all the time. So there it is. That's a real statistic behind it. Now you tell me, if you thought you wanted to move to Town B, where did you go? It's called the fallacy of ignoring the base, or the baseline, as this gentleman pointed out. Okay? Smart trap. Here's another one. We randomly drew the name of Bob from a set of 100 names that have 70 engineers and 30 doctors. So now who is Bob? Bob's a 30-year-old man. He's married with no children. A man of high ability and high motivation. He promises to be quite successful in his field. What is the probability that Bob is an engineer? Anyone take a guess? Don't be shy. Yes?
70%?
How much?
70%?
You think it's 70%. Anybody think different? I'm giving you a profile of Bob. You should have some opinion about what engineers are and doctors are, right?
He's married.
Psychologists have done this test time and again with all kinds of audiences. And by far the majority will say it's probably 50% or 45% or 60% or something like that. But it's been designed so carefully that this information tells you nothing whatsoever about doctors and engineers. So you would think in the absence of no information, this is sort of Bayesian stuff, right? In the absence of no information, what do you conclude? It's the underlying probability. So it should be 70% or 0.7, right? That should be the probability of that. So this is another heuristical bias that people have, being insensitive to prior probability of outcomes. That's what it's called. Here's another one. Student X obtained straight B's in the first 4 semesters in college. He's getting ready to select the schedule for his 5th semester. What would you predict would be his average grade at the end of the 5th semester? What do you think? Straight B's so far. Still a B? You think it's still B? Okay, that's fair. What about student A? Student Y? What do you think? 6 A's and 6 C's so far. What do you think that student is going to get? You still think it's a B?
More A's.
You're thinking more A's? Okay. I'll give you a little bit more information. Both students have the same major, which requires an equal number of science and humanities courses. Student X took only humanities courses so far, but student Y took an equal number of science and humanities courses, and he received A's and C's in both streams. Now, would you change your prediction based on that? Yeah, obviously yes, right? Here is the thing. The point I want to make, and this is very important because I do this in my consulting all the time, and I see this happen. When you are presented data that has no variance, straight B's, no variance, right? Everything is a B. When people make a prediction based on data that has low variance or no variance, they express a high level of confidence in their prediction. High level of confidence. That is actually misplaced in many instances. Okay? And that's called the illusion of validity. They think it's valid, okay, not having variance. And the way I look at this one is I do a lot of maturity assessments, right? When I do a maturity assessment, I get data all over the board, okay? It's all over the board. And sometimes there is consensus, low variance, and sometimes there is not, okay? As long as you're aware of this bias, you can then go after the high variance points and say, you guys don't agree on these metrics, let's sit down and talk about it, right? So it's the illusion of validity in reverse. Okay, but many people, when they run a maturity analysis or tests like that, they just look at the average. They'll compute the average and that's it. They don't take the variance and make something meaningful out of that. Okay. Oh, here's one more. I'm giving you all these exercises because even in simple situations, our intuition leads us astray. And in complex situations, it's very tough. I'll tell you a little bit interesting stuff about that in a minute. So which coin do you think is more likely to be fair? You know, a fair coin, right? Which one? Don't say it. He's a smart one. He's a smart one. Sorry? You think coin 1 is the more fair one, right? And why not this one? It looks kind of suspicious, isn't it? You agree with
I
that?
don't think you have enough data. But coins are.
Exactly. Thank you. That's exactly right. You got it. That's exactly right. It's hard to say. So here's the point. The essential characteristic called randomness, it may not be equally represented in small samples as in the larger population. Right? And what did I tell you about how human beings evolved? They look at small samples and they make their decision based on that. Right? That's what we do. And we are misled into thinking that our intuition with small samples holds for the larger samples.
But if you actually had to take the bet, which one would you take?
If somebody pointed a gun at me and made me take a bet, I would go for coin 1. Of course, yeah. That's a classic Bayesian.
As being the fair one or being the unfair?
The fair one.
The fair one.
Yeah. But only if somebody holds a gun to my head.
If you don't want to have to make the bet, but if you have to.
Yeah. And normally I don't make bets like that. So. Okay. Here's an interesting one. This actually comes up in business process management. And it's actually a mathematical term, right? And Zion knows more about this than I do. But the point is that, if you look at a local optimum, it need not be a global optimum. You understand? It need not have to be, okay? But we come across that in process management. So we spend a lot of time using Six Sigma techniques to identify process improvements in business processes. But if you look at a siloed approach on a process and you try to optimize that, well, you get your optimization, fine. But guess what happens to the upstream or the downstream process? It gets messed up. So now you go and work on this one and you optimize this one. But together, they don't necessarily optimize. I'll give you an interesting story to drive home this point, okay? You ever heard this phrase, wing to wing? Wing to wing, ever heard this phrase? Or how about end to end? An end-to-end process, end-to-end solution. The original idea there was called wing to wing, and it came from GE's aircraft engines. And the problem was that they serviced their engines, right? All GE aircraft, you have to service, all aircraft have to service their engines. And to do that, they unmount the engine from the wing and put it in the tarmac, and then they ship it to a facility where they have to service it, and then they bring it back, and then they mount it back. Okay. Now, unmounting and mounting is not something that you and I can do with a Phillips screwdriver. It doesn't work like that. It's a very complex set of tasks that need to happen, right? So the people who do that are specialists, and the people who service engines are a different set of specialists. Okay, believe it or not. And they found, and GE did this huge project with several of their customers, and they found that they said you have to use Six Sigma techniques and unmount and mount pretty quickly, and they hit all their targets, no problem. And then they went to the repair facility, the servicing facility, and they said, you guys must use Six Sigma techniques and do your turnaround pretty fast. They also accomplished it. But the customers, meaning the airlines, for them it made no difference at all. They still saw delays in getting this back, functional. Why is that? Because both optimized, both achieved what's called a local optimum, right? But the total time was not optimized. And why is that? Precisely. This thing was sitting on the tarmac, and it sat there for several hours until somebody came and picked it up. That was the missing link. That's why GE said, wing to wing, we must optimize, which is you must seek a global optimum. And do not be misled and fooled by thinking that just because you have solved a local optimal problem, you have achieved optimality. It doesn't work like that. And in a lot of the analytical techniques that you will use or you present to your audience, right, you will see that issue. You will present to them what looks like a fantastic graph and a great average and the variance and key performance indicator or whatnot. It may not be the global optimum, right? And as long as you're aware of that situation, you can give better guidance to your own users, right? So again, all these are pretty simple things. So we have this misconception of the gambler's fallacy, right? You know this stuff, right? Right? It's been handing heads all the time. It has gotta make a tail now, right? And you mortgage your house and bet on the tail, okay? But most phenomenon like this, they don't have a memory. They don't care what happened before, right? This actually happens in the stock market, by the way. Very interesting thing, right? You know how many of you guys trade or invest? Well, quite a lot, right? Now, when you trade and invest, we all have this. We'll say, for example, we'll say, I don't want to lose more than $1,000, and I want to make $3,000. That's what we think, right? Guess what? The market gives a rip about what you think. It will take your money out in a heartbeat if you're not careful. It will refuse to give you your rewards. It doesn't care what your goals are. It doesn't care what your risk tolerance is. If you don't put protective stops in place, you are finished. Okay? So there's no leveling mechanism in there except to take your money. That's about it, right? So this is what's called the gambler's fallacy. Okay? I've got a couple more just like this. Can I do an interesting experiment? I've never done this. Okay? I want to do an interesting experiment. You guys game for this? Take a few seconds, okay? The best way to do this is to take this set of people right here and this as two groups, okay? Now, I'll give you a problem, a mathematical problem, and I don't want you to calculate it. I want you to estimate it in 5 seconds. Gut feel, 5 seconds estimation. That's it, okay? But I want everyone on this side, on my right, to close your eyes and not peek until I tell you to. No peeking, just close, okay? Everybody on this side, okay? 5 seconds, estimate and write it down. Go on, quick. Okay, done. You got it? Okay. Now, this group, open your eyes. You guys have seen this. I want you to look at this product and estimate that in 5 seconds. Go. 1. Stop. Done. Okay. What did this group, give me some sample answers that you came up with. 1,000?
Half a million.
You're a statistical outlier, I'll discount you. Huh? Yeah, but what is your answer? Few thousand? Few thousand? Yeah. Okay. 1,500, 1,000, few thousand. What did you guys come up with? Be honest.
5,000.
5,000? 5? 5,000? How much? 100,000? See what happened here? You guys came up with smaller numbers. You guys came up with larger numbers. Get that? 1,000, 1,500, 2,000, a few thousand. The million I will discount it. So you guys came up with 5,000, 100,000, something. Is that right? You get this idea? The actual answer is, of course, 40,320. Why did this happen? The way I presented the problem to you, you guys did. You started with this, right? And you underestimated it. The other group started from here. We always multiply left to right, this normal human tendency, and you overestimated it. Okay? This is, interestingly enough, it's called it's not a fallacy, it's a heuristic of insufficient adjustment. And psychologists have done this time and again. All kinds of audiences, including even mathematicians, they typically underestimate or overestimate depending on where they start. Okay? I'm very pleased that this research confirms that because I've never done this in public before. So this is great. I love it. Okay? So you see what happened there, right? You understand what's going on? So the way you present, and you guys know that when you present a bar graph, if you don't have the right base, right? If you don't put the right base, you can see very small graphs that say, oh, that's like nothing. The increase in profits are like nothing, right? We can have all these illusions when you have, all kinds of graphs going on. So all that is part of, this kind of metric. I don't know, just one more, I think. Let's do this one too. Okay. So which bet would you take? And please don't calculate. Use only intuition. I want you to take only one of those bets. Which one would you take? Okay, so you would take 3. Okay, who would take 2? Anybody take 2? You guys are not betting guys, are you? I'm in the wrong crowd, right? I should go to Las Vegas. Anybody take this? Oh, now we see, excellent, very good. So now we're taking this, right? We saw one person do this. How many would do this one? Why nobody's doing 2? 7.
It's an ant thing, so multiply, your probability keeps dropping every time.
So here are the true probabilities. Okay? The true probabilities, convert them to odds. This one is actually the highest probability. So you would actually come out ahead if you play this game again and again, right? So, but the interesting part is that most people actually pick this one, followed by this one, followed by this one. Studies have shown this. What is the point of all this? We don't have, and by the way, let me point out one other thing. All the studies that I'm talking about have been conducted not only with lay people, but also with sophisticated statisticians, psychologists, and knowledgeable people. but the results have been very consistent. And as human beings, we don't have good intuition about opportunities. We don't. Okay? We struggle with this all the time. And which is why it kind of makes me really funny, when I read a Gartner article that says something, they predict and say something with probability 0.8. And I say, how the heck did they come up with that one? So here's another thing too, and this has,
Yeah. How is that possible on previous? So like even if you just try number 3 once, isn't the probability 10%?
no, do the math.
One big red marble.
No, that's your take-home exercise.
At least once.
Trust me, this is good. This is right.
Oh, at least once.
At least once.
I'm reading the thing. Okay.
This probability
Sorry.
is the 1 minus that probability. Just so you know. Okay? All right. Now, this is an interesting one because I'll tell you why. Bear with me for a second. Would you all believe that rewarding a good outcome increases the likelihood of further good outcomes? If you reward your kid for doing well at school, they will continue to do well, okay? And punishing bad outcomes decreases the likelihood of further bad outcomes, right? You believe that? We all like to believe that, don't we? Okay? So here's the thing that they did with flight instructors. So flight instructors who praised their students on doing a good landing saw poor performance on subsequent landings. When they scored their students on a poor landing, they saw the performance improve on subsequent landings. Completely counterintuitive, don't you think? So the flight instructors concluded, therefore, that they should keep punishing their students and not reward them. Okay? Why did this happen? So the conclusion was punishment is more effective than reward. What is the management implication of something like this? It's horrible, right? So managers are punished for rewarding and rewarded for punishing. This is exactly what happens in corporate America, by the way. And why does this happen? It's because people have what we call a misconception of regression. It's a regression to the mean or a stable state. So things always regress somewhat. In the long run, you can change, but in the short run, things regress to the mean, so to speak, right? And that's why you have this issue. You see how these things have impact on how corporate America behaves and treats their people, for example? It's classic, right? So everything that you do here in terms of assisting decision making for corporate America, right? It has implications for that. That's the point I'm trying to, kind of sneak into your head. There is one more. Do you guys know what transcendental numbers are? And I think this is probably the last one. Anybody know what a transcendental number is? It's not a spiritual new age stuff, but, huh?
Transcendental number will not be rooted in any arbitrary place.
You give me examples.
I, E.
Yes, I, E, and?
You can construct them by, if they construct them by starting with one, then you add.
Yep, I know what you're talking about. But you give two examples, right? Classic, E and pi. Now, Zhang and Professor Tang and I have done this so many courses, but that's all we can come up with, E and pi. You ask any mathematician, right, immediately say, give me transcendental numbers, E and pi. What about whole numbers? Can you guys give us examples of whole numbers?
Integers, positive.
Whole numbers, yeah.
0.
1, 2, 3, 4, 5. And we can do this ad infinitum, right? Until we get all sick and tired, right? You understand? So, we were able to come up with infinite number of examples for whole numbers. But right off the top of our head, we could only come up with 2 examples of transcendental numbers. Right? So far? Okay, you with me? So, which are more numerous? Whole numbers or transcendental numbers?
Cardinality.
Hmm?
You're right. Very specific cardinality is density.
There you
know
go.
how many
Huh?
you don't know how many transcendental numbers there are.
I understand that. But simply based on your intuition of the number of examples you could come up with, what do you think, right? I know some of you are thinking, but you're not saying this. Most of you think that there are a lot more whole numbers than transcendentals because how many can you really think of? transcendent numbers are really funny beasts, by the way, on the number line. So it's kind of tough to find them, right? So you might think, they're kind of rare, e and pi, and maybe once here and there you kind of muck around, you'll see some, okay? But whole numbers, by golly, they're all over the place, right? So you think whole numbers are a lot more than transcendent numbers, but guess what? Whole numbers are countably infinite, but transcendent numbers are uncountably infinite. In other words, to those of you who don't know this stuff, the infinity of transcendent numbers is larger than the infinity of whole numbers. Okay? What does this mean? Psychologically, it's called the bias due to retrievability of instances. If you cannot find enough instances, you think that the underlying phenomenon is rare. If you can easily find examples, you think it's more frequent than it is. Okay? And if you read the literature, there are really classic examples on how this happens in real life. Okay, not just mathematics, but in real life. Okay, so think about that. I won't go through that. We already talked about it. So all the stuff that you saw just now, I just kind of grouped. This is not my grouping, by the way. This comes from Judgment Under Uncertainty, Heuristics and Biases by Kahneman, Slovic, and Tversky. Classic book that I read 20 years ago, and I was so impressed by this. It's a highly readable book, by the way. It's not full of mathematics and stuff. It's very chatty, very readable, and powerful. And many of these examples are taken from that, and you'll see, your eyes will be open to how we as humans think, analyze, and make decisions. It's absolutely incredible, right? So I won't go through all, but you saw some of these things just now, okay? So the role of heuristics is really. So here's the other thing that I want to say. If some of you got some of these things wrong, don't feel bad, because every one of us, whether we are, a PhD in statistics or a third world peasant with dung on his feet, we all make the same mistakes. This is universal, by the way, okay? And they have nothing to do with, by the way, so they have nothing to do with things like wishful thinking, mental illness, and nothing like that. It's nothing related. It's the basic cognitive apparatus we are born with. That's what it really is, okay? And strangely enough, payoffs don't influence them. So if I had dangled, thousands of dollars of bills saying, if you get the right answer, I'm going to give this to you, it will not improve your performance, trust me. And they've done this, it doesn't work. Payoffs don't correct for these biases in human beings. They don't do that, okay? So lay people and experts equally succumb to them. And so correction of these biases is pretty critical. And how do you do that? There are several techniques to do that. And I think they should be, this is my fervent hope, if there's nothing else you got out of this whole thing, that you will understand and appreciate the extent to which biases are prevalent in our thinking, and that you will get to learn more about them. And as you do your analysis in your analytical thinking, in your software that you're writing, in the consulting that you're doing, you're aware of these things and you educate your users and present them the right way. That's my hope, okay? Because without that, it's all going to be, not so good. So this comes to the last point I want to make. Decision making, you have all kinds of techniques going on. People have heard some of these things. You probably have not heard about the analytic hierarchy process, but it's a very, very powerful technique to use. Most of the time, of course, it's sort of, hey, just, go with whoever is shouting the loudest. Okay? You all do the eeny, meeny, miny, mo decision algorithm, how to pick, right? When my daughter was very, very tiny, we went to Toys R Us, and, she was going to pick one Barbie doll out of like 3, and she just couldn't do that. She didn't know which one to pick. And I said, honey, I'm not buying you all the 3. You have to pick one. And I said, why don't you do the eeny, meeny, miny, mo? And she said, okay, eeny, meeny, miny, mo, catch a tiger by the toe. If he hollers, let him go, eeny, meeny, miny, mo, something like that. And then she would arrive at that. But guess what? She didn't really like that. So she would go back and redo this whole thing. And she would land at somebody else. So I don't really like. So this eeny, meeny, miny, mo procedure for my daughter was not a procedure for selection. It's a procedure for elimination. That's what it turned out to be. So kids kind of use this very creatively, right? But, I don't mean to be flip, but the thing is that in many, many cases, it's really nothing more than political fist fights. They just win, okay? That's what decision making in corporate America for the most part really is. Okay, that's what it's all about. Okay, so we also do pattern matching, case-based reasoning. 90% of the time, it's been shown that human beings use case-based reasoning. We actually don't, in our mind, construct decision trees. When was the last time when you went hunting for a car that you actually created a decision tree? Anybody do that? No? If we don't do this, lay people will not do this either, right? So we all don't do this, even though those decision trees and other techniques are prone to be very powerful. They kind of expose some of your biases. Okay, you know what a pairwise comparison is, for example? A pairwise comparison in multiple alternatives in 2 grids, right? If you do the pairwise comparison, you can get into what's called conflicts. You can prefer A over B and B over C and C over A, which is a transitive conflict. Okay, so you can get into interesting situations like that, but there are techniques to help you get away from things like that, right? But we don't use them. Why not? We just go with pattern matching. Oh, the car looks cool. I saw a break over that in the magazine ad. I'm going to go with that. Okay, we use patterns, right, on a lot of these things. So the point is that you've got to kind of get away from that. So my final takeaway is that for all your users, we being in the forefront of this analytical revolution we're thinking about, right? We have the responsibility to educate our users, to let them get more sophisticated. Ourselves understand what all these issues are, right? And expose some of these biases in judgments, in decision making, and help them with that, right? And for us, experts, of course, we need to be more diligent in applying the right analytical models. We have to examine the nuances behind it, where it's applicable, what its limitations and constraints are, and so on and so forth, right? We need to present the right choices. We also need to explain the risks, and we need to help users overcome all kinds of biases. You'll see it's down there, but that's what it is about. Okay, can it make sense? Well, that was it. Any questions? Comments? Yeah.
Excellent presentation, and thank you very much. I think this is really an important topic. But where I work, I very quickly run into the problem, and I can have any number of reports or data or statistics, and it doesn't matter because the management doesn't buy in to even think that those things are important. And it's intensely frustrating to me because I can do whatever they ask me to do, but they don't even think it's at the point it's valuable. So have you had any success with getting management to buy in to think that analytics are important, other than just, oh, everyone's doing big data, we should do that too?
Yeah. I've had a limited amount of success doing that because maybe it's the way I present. I don't know how you present, I don't want to presume, but I don't give somebody, have my team just give them some report, right? That report is always accompanied by either it's a return or it's a presentation of choices, alternatives, some sort of a business tied to that. So we will say, for example, we found that the average spend of your credit card customers in this particular bracket is X, Y, and Z per year. Okay, but when we present that, we also say, but here are all the other circumstances that will invalidate what we just said. Okay, some of these are in low-income areas, for example. So we haven't done the splitting off that. So we give all these little caveats. So people say, "Oh, I see," and then they will say, "Okay, can we get that information too? Can you put more confidence around this whole thing?" Right? So sometimes you have to present it like that. You can't explain statistics to these guys, right? So you have to come back and do it a different way. But it's a very good question. It's a tough thing to do, though. I completely admit that. Okay. Yeah.
So you mentioned the book by Danny Kahneman, Diversity. So I don't know if you're aware of this, but Danny Kahneman has a new book out. It was a couple years ago called Thinking Fast and Slow. Yeah.
Oh yeah.
So he kind of updates not just about heuristics, judgment, like biases and heuristics. And the way he frames it is in terms of your different types of brains.
Right.
So the one that's more logical and the one that's more emotional.
That's right.
The one thing he has to say about biases is that becoming aware of your biases makes you less prone to know about them in the future.
Right.
So I'm wondering what you think about, what are the most important biases that would threaten analytics? You presented a lot of them, but I'm wondering, like, what are the most important ones?
Yeah, that's,
We can't present, like, 20 of these to managements,
Yeah.
but we can present a couple of these. So I'm wondering which ones you think are the most important.
Yeah, most of the judgments and the heuristics from that book, right? If you look at representation and adjustment, availability, those kinds of biases, I think those are very prevalent. And I say that because they've all been identified in the course of regular interactions with actual people. Okay, so I think those are important ones. Now, if you're asking me which analytical model could I take a bar graph or a hypothesis test or a regression equation, and what biases might play into that one, I don't know. I mean, I haven't made that map yet. Okay, but it's a great question. I mean, these are the questions you guys should be asking and thinking about, and I'm glad you're doing that. Absolutely. Okay. Yeah.
So this is very interesting. I'm guessing a very different perspective than most of the people who do management, healthcare, and big data is becoming one of the watchwords of how you're analyzing the results of what we've done. And it was incredibly interesting to look at this from the perspective of what are the decisions we make as managers, where aggregating data actually does provide insight potentially into how to allocate resources, where we're going to be effective, et cetera. But at the decision-making point where it influences the actual behavior, the biases are incredibly different. The physician who's standing in front of the patient, knowing in theory that we're overusing antibiotics, still has to make the decision: do I prescribe an antibiotic? Do I not prescribe an antibiotic? And if so, which one? And
Right.
especially when you talk about the issues of penalizing or rewarding behaviors, the risks associated with those decisions are completely disconnected from the decisions that we make at the management standpoint. So, I look at this room, people are probably going to be on the back end developing a lot of the tools that we will use like that. It's important to think of them both from the management perspective as well as from the individual decision maker perspective. And it may actually be important to look at big data from those different perspectives in developing the tools. But this is fascinating.
No, I appreciate it. Yeah. No, it is a fascinating topic. It's something that I've been enamored with since ages, right? And so let me give you one other color to that one. You know the definition of an expert? Not the flip one that says anybody who is more than 50 miles away from his hometown. Yeah.
Less until they know absolutely everything about nothing. And the generalist is someone who learns less and less about more until they know absolutely nothing about everything.
Yeah, there's this lady that ran into a guy at a social function, and she said, what do you do? He said, I'm a surgeon. And she said, oh, what do you specialize in? And I said, I'm a naval surgeon. And she said, oh my God, how you guys specialize? She thought naval surgeon. But the hallmark of an expert is not only can they give you the actual solution and decision, but they can actually explain the reasoning behind it. This idea, this whole concept of what constitutes an expert actually made its way into what we call expert systems design. And, I've been dealing with, I've actually returned expert system shells myself. Tong and I, we worked for a professor who is, one of the leading lights on expert systems. And so we design expert systems in such a way that not only can they present the conclusion, but they can take you back through the chain of reasoning that led the system to conclude that, right? And the parallel to analytics is that if you present your analysis in such a way that you have choices, risks associated with that, and you expose the underlying biases and say, caution, don't think that this means X, whatever that is, right, that bias is. And if you present it like that, I think it adds more tremendous value. And the more of us do that, slowly the management monkeys will start getting, they'll start learning about this stuff too. Sorry, I was one. Okay, cool. All right, there's nothing more. Thank you very much. You've been a great audience.
Beautiful talk. Thanks, Karen. So I have a book giveaway. So I have shortlisted few names. So I'll spot out the names, and if anyone is in the audience, so Sarabjot Kaur, awesome. This is an awesome book by Aaron. So if you want to be assigned to them, so feel free. Thank you guys again, really appreciate it. And if we have some things there, you guys can take it. That's all right.